everyone, welcome back. Today I am doing a video that I've actually been meaning to do for like a year and a half, and somehow I just never got around to it. And so this video may not appeal to my usual followers. It's kind of geared more toward my students, more toward the parents of my students, and even incoming college students who hear about this new math, but maybe have no idea what new math is. Math has changed a lot from when I was a kid, and even from, my sister's like 8 years younger than me, but even she doesn't know, the new math, because it's just different with the new learning standards, programs like Everyday Math, Singapore Math. A lot of people cannot help their children do their homework, or they tell their children that the teacher's doing it wrong. I cannot tell you how many times I've had children take multiplication homework home only to have it come back with a note saying, "I don't think you know what you're doing," or something along those lines. So this is for those people who have no idea what the heck new math is. Today's video is going to focus on the variety of multiplication strategies. And if this video does well, maybe in the future I'll do one on division. I'll see how this goes. So right now I'm going to turn the camera around and show you what on earth is new multiplication. So the first strategy I'm going to show for the new multiplication is what we call area method. And area method is probably very similar to something you already know, and when you were in high school you probably had to do problems that look like this. You're going to buy carpeting for your living room. The living room measures 10 feet by 12 feet. How many squares of carpet do you need to fill the entire living room? And the answer was 12 times 10 equal to 120 feet square. So hopefully you recognize these kinds of problems if you've ever bought carpeting or painted a wall. This is a very practical form of multiplication that is relatable to real life scenarios. So we like to use this strategy for larger and larger numbers. Let's say you have this problem. You have 57 times 32. This is not a problem that can be solved easily in your head, and when you did this the old-fashioned way of writing 57 times 32 like this, inevitably what ended up happening when we were learning math is you had to do all the multiplication, all the carrying, and then when you got to this 3, you had to put a placeholding 0. And no one ever really told you why you had to put a placeholding 0. You just had to do it. And then when you multiplied again, you had even more numbers being carried on the top, and you had to remember to add this one, not this one went to the 2. There was a lot of ways to make what our teachers used to call silly mistakes or simple mistakes, but inevitably what the result usually was is we got the wrong answer because there was just too many numbers being carried up here. You forgot to put your placeholding 0. There was just a lot of ways to make a mistake. Yes, this is how we were taught, and we survived it. We managed to finally learn it eventually. But with the new math, we really want the children to know why the answers are the way they are. We don't want to tell them, put a placeholding 0 because I said so. That's a rule. So with area method, you would literally do something like this. All right, and right off the bat, what I've done with area method is I've busted up my 57 and my 32. We teach the children that the number 57 is made of 5 tens and 7 ones. 32 is made from 3 tens and 2 ones. And we create an area box. One thing that what the new math focuses heavily on is finding the zeros, because zeros are easy. You know, if I look at 30 times 50, at the end of the day, my original problem is just 3 times 5. Most children know 3 times 5 with no problem. It's 15. And then they're taught to add their zeros because these are in the, this is 5 tens, 3 ones. So this becomes 1,500. Now I'm going to do 7 times 30. Again, my original fact is 7 times 3, which is 21. And then I add my 0 here for the tens place. Okay. I move to the bottom, 2 times 50. 2 times 50 is 100. 2 times 7 is 14. These are the 4 partial answers once you do this multiplication. And then you just add it up. Now the children are able to see where all these zeros come in. With a problem like this, you don't have to explain a place holding 0. It doesn't even come up because you understand right away that, you know, this is tens being multiplied together. These are ones being multiplied. The problem solves itself and gets rid of a lot of those simple mistakes we used to make with these kinds of problems. Now, for those of you who are going to say, but do I want my children to do their multiplication like this for the rest of their lives? No, this is not the strategy we want our students to be using once they become adults out in the workplace. This is the strategy we use to introduce the concept of double-digit multiplication, so this way they understand the place value. They can visually see the place value. All right, so this is one strategy for new math. And I'm going to move on to the next one. So the next math that I usually introduce in my classroom, so I'll usually do area model first. The next one will be called partial products. And partial products starts making the multiplication look more like the traditional algorithm that we are used to. So let's say I have this problem. All right, 6 times 78. We would write it in a way that you guys would be familiar with, but instead of doing it the way we were taught, we're still focusing on teaching the understanding of that place value. I don't want my students to say 6 times 8 is 48, 6 times 7 is 35. Because the truth is, this 7 is not really a 7. This is a 7D. This 7 is worth 7 tens. It is significantly larger than just a regular 7. So with that in mind, for partial products, we tend to actually start from the front. So I would have my students say 6 times 70. And in the beginning, so that they remember this is a 70, I might even have them put a 0 there, so that they see it's 6 times 70, not 6 times 7. So 6 times 70 is 420. Now 6 times 8 is 48. 0 plus 8 is 8. 2 plus 4 is 6. 4 plus nothing is 4. Final answer is 468. By doing it this way, by teaching the children, this is 7D, not 7, again, it eliminates that rule we were taught of the place holding 0. And, you know, a lot of people didn't even know why you were putting a 0 there. You just did it because that's what the teacher told you to do. And the minute they realize that this is 70, suddenly this 0 makes sense. It's actually part of the answer. Now I will say this gets a little bit more complicated when you're doing double digit time double digit, which I'll do one of those now. And I'm going to use the same problem I used for the last problem. I'll do 52 times 37. So we would write it the way you're used to. All right. But again, I'm not just teaching multiplication. I'm teaching understanding of the concept. I want them to literally in their head see these numbers for what they really are. So over here, they're going to bust up their number. All right. And now we call it multiplication wrestling. That's what the book calls it. But again, you're going to find your partial answers. So I'm going to start off with 7 times 2, 14. 7 times 50, 350. 30 times 2, 60. 30 times 50, 1,500, all right? And then you add them up. $1,824. So, and the reason you call it multiplication wrestling is the 7 gets a turn with the 2, the 7 gets a turn with the 50. 30 gets a turn with the 2, 30 gets a turn with the 50. So everyone is taking their turn. And you get the 4 partial answers, you add it all up. Eventually, the goal is to get the children to do this in their head and not need the written model anymore. So if I do another one, let's do 41 times 28. All right? If I write it like this, I want the children to literally say, okay, 8 times 40, 320. 8 times 1, 8. 20 times 40, 800. 20 times 1, 20. 1,148. So by saying 20 times 1, that place holding 0 is a natural part of the answer, not some rule that you got to do it or else. So this is the partial product method, and I hope this makes it a little less confusing for parents. Right. The last new math that really seems to confuse the heck out of my parents is Lattice. And I will be honest, I teach Lattice last. In my classroom, I will usually start off with area model first. Then I will move to partial product. Then I will teach the traditional algorithm, which is what we grew up doing. And finally, I will teach Lattice. Because once the children learn Lattice, it's the only way they want to do it. I have a teenage son who is 16, and he still only wants to do Lattice for his multiplication. And part of that's because it's really easy. When you look at it as a parent, you're thinking, what is this? This is gibberish. But once the children learn it, they absolutely love it. So I'm going to start off with a big one. I'm going to do 5 times 672. All right? And the first thing you do is for your biggest number, you draw that many boxes. All right? 672 goes there, and then this 5 will go on the side. And if you want to put a little times table right there, you can. The next thing you do, This is a way of getting the place value in there, and it's almost like a way of cheating. So that's the best way I can really describe it. Cross over, cross over, cross over. 5 times 2, 10. 5 times 7, 35. 5 times 6, 30. 0, 5 plus 1 is 6, 0 plus 3 is 3, 3 plus nothing is 3. Final answer, 3,360. There was no thinking about tens, no thinking about hundreds, no thinking about place holding zeros. Because the answer is solved as a sideways addition, the place holding is built right into it. So a big problem like this literally is turned into a very simple problem. 5 times 2, 5 times 7, 5 times 6. It takes a lot of the thinking out of the multiplication. And that is the reason why I will always teach this strategy last. Because it is honestly, for lack of a simple term, it's a lazy way to do multiplication. So I want to make sure that before I teach my students how to do lattice, they understand long multiplication. They've got it down, they get the place value, and they're good to go. Once I know that they competently understand all of the reasoning behind why these answers make sense, that's when I teach them to what I consider the lazy way of doing multiplication. I'll do one more problem just so parents can really understand why kids love lattice so much. Alright, I'll do a bigger problem. I'll do 74 times 506. Now, I have 5 digits this way, so I'm going to make sure I have 3 digits this way. So I'm going to need 3 boxes again, all right? But this time, instead of only having one number here, I have 2. So I need to write my 506 up here, but then I have to write my 74 over here. So what that means is now I need a second row. And if this was a 3-digit number, I would add even a 3rd row to make a place for every digit that I'm working with. And then, just like before, you draw your crisscross lines. All right? And usually, if the children make a mistake in lattice, it's because they weren't neat. I will say that when it comes to teaching lattice, neatness is everything. And then you start. 7 times 6 is 42. 7 times 0 is 0. You put 2 zeros in there because this half is for the tens, this half is for the ones. 7 times 0 has 0 tens, 0 ones. 7 times 5 is 35. 4 times 6 is 24. 2 tens, 4 ones. 4 times 0 is 0. 0 tens, 0 ones. 4 times 5 is 20. 2 tens, 0 ones. And then just like last time, you're adding it sideways. So, because with a problem like this, you would have actually had to have put 2 place holding zeros in there. Not anymore. So now 4, 2 plus 2 plus 0 is 4. 4 plus a row of zeros is 4. 5 plus 2 is 7. 3 plus nothing is 3. 37,444. So, yeah, this is why the kids love lattice. A huge problem like this, instead of having those long multiplications that we used to do, it's literally turned into just 1 digit times 1 digit multiplication. 7 times 6, 4 times 6. So as long as the children know their times tables, Lattice is insanely easy for them. So, and if you really want to help your 3rd, 4th, and 5th graders, the number one thing parents can do at home is to have their children memorize their basic times table facts. I cannot stress that enough. I admit right now in my classroom, half my class does not know their times tables, and so they're using a multiplication chart. But the class has already been told that by March 1st, I'm taking the charts back. They have to have them memorized, because at some point, when they're taking tests, they're not allowed to have a cheat sheet to take the test. They really do need to memorize these facts. I hope you really enjoyed this video. I hope it explains things for you. I hope it helped you, especially if you're a parent to one of my students, or just a parent in general who has children in the education system right now who are bringing home homework and you just have no clue what to do to help your child. So I hope it was really helpful. If you like this video, be sure to give it a thumbs up. If you have comments, I would love to hear from you, so please put them down below. And if you want to see more from me in the future, click that subscribe button, and I'll talk to you later.